Hello, and welcome to the first math course video. When I planned this course, I wanted it to be from as basic as possible. So for this video, we will go over the very essence of what are numbers and what different type of numbers exist. Now, before we start this math course, I would like to recommend you a couple of books that I think are extremely helpful, and at least in my journey to learn mathematics, they were pretty helpful. So these two books are my bread and butter right here. These are the two math books that really taught me everything I know about math. Uh, Big shout out to Georgina, my high school teacher, for providing us with this recommendation for this book. It's not something that I have seen anyone else use, but Pure Mathematics by Sandler and Thorning, an extremely, for me at least, an extremely emotional book, and at the same time, an extremely informationful book. And then on the other side, we have Mathematics Handbook for Science and Engineering by Leonard Rode. Rode, right? I don't know, Swedish name. This you might not find everywhere, as I assume because I purchased it in Finland. It might be limited to the Scandinavia region, but I'm pretty sure you can order it online. However, this Understanding Pure Mathematics, that's a book that you can probably find online and you can order, and you can even find PDFs. But remember, don't pirate. Wink, wink. With that being said, let me take the books out of here. Let's start talking about numbers. Naturally, the first numbers that we learn are the numbers between 1 and 10. And there is a very big reason why that is. We have 10 fingers. And the fact that we have 10 fingers has changed how we do mathematics quite a lot. But we will talk about that in a future video when we talk about basis and what does that mean. However, these numbers that I just mentioned from 1 up to 10, and then as we gradually advance, 11, 12, all the way up to the biggest number that we have counted at or that we have ever spoken in our life, and then naturally positive infinity. They're called natural numbers, and they are denoted by a capital N. So these numbers include all the numbers from 1, 2, 3, 4, all the way up to positive infinity. And this 8 looking sideways character, that is called the infinity symbol, but we will talk more about math terminology and different types of characters used in maths in a future video. However, just keep in mind that this little character, which I drew horribly, is denoting infinity. However, as you can see, these numbers here, they are lacking something. They're lacking something that even as a kid, you might have a faint concept of what it is and that it exists. And that's the number 0. And I'm using number here very lightly because there is this uh, philosophical, I guess, debate, not very like mathematical, about whether 0 is a number or not. However, that's why we have created another set of numbers called whole numbers. And while n is globally recognized as a symbol for natural numbers, w is not actually recognized as the symbol of whole numbers. So you will see it in literature used quite often. However, it is not the standard. And the only difference between whole numbers and natural numbers is the addition of 0. So otherwise, they look the exactly same. Before we move any further and discuss the next numbers that exist, so the next set of numbers, I would like to talk to you about something that when I realized, it was quite shocking. Although we tend to write numbers as 1, 2, 3, 4, and so on, these natural and whole numbers, they are actually missing something that we are dropping just because we simply understand that they're positive. And that's the positive sign. So 1 is the same as positive 1. However, because, well, positive numbers are usually the numbers we mostly work with, we drop the plus sign. And that is actually something that I feel like creates a lot of understanding issues as we move forward and we talk about other types of numbers like negative numbers. And why is that? Because we think of numbers as quantities, like we have one finger, two fingers, three fingers, and so on. However, there is another way to think about numbers, and that's introducing an axiom. Axioms in mathematics are extremely important. And the first axiom that we should learn is one dimensional, and we will talk also about dimensions much, much later. However, I want you to imagine that there is a huge line that starts from as far in the negative side as you can think of. And so it goes to the basically negative infinity all the way to positive infinity. And somewhere, actually not somewhere, dead in the middle in that line sits 0. And then all the numbers above it, so 1, 2, 3, 4, and so on, are on this side, and all the negative numbers, -1, so on, are on the left side. However, what does it mean to be on the positive side? I would like to introduce you a more intuitive way of thinking about numbers, and that is the number line system, where its number tells how far it is from 0. So 1 is from 0 to the positive direction, so to the plus direction. So this is the plus direction, and then this is the minus direction. So 1, it is to the positive direction, to the plus direction, 1 unit. 2 is to the positive direction, 2 units, and so on and so on. So we have 1, 2. So this plus that we are dropping, it is quite important, and it helps a lot to understand that, well, it should be there, but because we're so accustomed with these numbers, we decided to drop it, which obviously we don't do for negative numbers, for example, but we have decided that for positive numbers, that is okay. So with that being said, let's talk about integers. And they're denoted by a capital Z. Yeah, I know that sounds a little bit weird. They're called integers, but they're denoted by a capital Z. But integers basically include numbers all the way from negative infinity to positive infinity. So we have 0 somewhere here, then we have +1, +2, +3, all the way, and then on the other side we have -1, -2, -3, all the way to negative infinity. So the main operations that we can do in mathematics are addition, which is denoted by a plus, subtraction, which is denoted by a minus, multiplication, which is denoted with whatever everyone at that time wants, but usually denoted by an X or a little dot. However, I will be using X. And then there is division, which is denoted by a slash. And actually, this slash can be slightly tilted, or it can actually be completely vertical, also like this, where you have the number on top and the number on the bottom. What I would like to focus on is how do these operations relate to the number line? Well, addition is quite simple. It's the first one that we learn. to add something is to add another unit to it. But it's not quite as simple as it sounds. So if we go back to our number line, let's start from 0. And we want to say that to 0, I want to add 2. How does that actually happen on the number line? Well, you have to recognize that 2 is plus 2, as I mentioned earlier. And what does that plus 2 mean? It means direction towards the positive side. And what does addition sign? It means that we are going to move towards the direction that the sign of the number indicates. So since plus 2 has a positive direction, then on the number line, I will move towards 2 units. So that means I will go from 0, 1 unit to plus 1, 2 units to plus 2. And you might be like, whoa, that was extremely confusing. Why would you explain it like that? Hear me out, hear me out. So what happens when we have addition to a negative number? So we say 0 plus negative 2. And I'll use parentheses here, which is what you will see used when we're dealing with negative numbers within a whole equation. So what does this actually mean? It says start from 0 and move towards the direction. So plus is move towards the direction of negative 2. So what direction does negative 2 have? Well, it has a direction towards the negative infinity. So its direction is respected, and therefore we move 2 units from negative 1, negative 2 to the negative direction. So we moved 2 units from 0 all the way up to negative 2. So let's talk about subtraction. What does subtraction do? Well, subtraction is quite actually similar to addition. However, the main difference is that in subtraction, the negative sign changes the direction of where we're heading. So if we have, again, 0 minus 2, and we know that 2 is nothing but plus 2, what does this negative sign actually do? Well, this negative sign changes the direction of where we're heading. We are at 0, and now we're going to go towards 2. However, we're going to change the direction. So instead of moving to the positive direction, we're going to move to the negative direction. So in an essence, we will do what we did also earlier when we did 0 plus negative 2. And there is a very big reason why that is. Whenever we have a minus and a plus, minus takes over, which dictates the direction, again, towards the negative direction. So if you ever have plus minus or minus plus, so plus minus in this is this case where you have 0 plus a negative number, and minus plus is where you have 0 minus a positive number. Well, in both cases, you will be left off with a negative. And that's why we say that this is equivalent to 0 minus 2, but this is also equivalent to 0 minus 2. So from 0, 2 units to the negative direction. What happens then when we subtract a negative number? So what happens when we have 0 minus 2? So what did we say that the negative sign does? The negative sign changes the direction of the number. So when we have negative 2 has a direction towards negative infinity, But now this minus sign reverts the direction. And what we're left off is 0 plus 2. So we start from 0. We want to go 2 units to the positive direction. And this concept, to me at least, in the beginning, it was quite difficult to understand and grasp. And that's why, at least, I'm trying to showcase it on the number line, because I think it makes more sense when you think of it as directions. So either they have a direction towards the positive infinity, and they have direction towards the negative infinity. And in mathematics, actually, you will see that, as we will talk later about limits, there is a concept of negative 0 and plus 0, which is yeah, it's quite hard to grasp at this moment, at least, what that might be referring to. However, that's something to keep in mind. So just like we have for all the other numbers, we can have -1 and +1. You can also have it for 0. Whenever you have minus minus, this minus sign will reverse the direction of whatever this next upcoming sign is. So minus reverses minus, which becomes plus. Minus reverses plus, which becomes minus. I'm going to demonstrate that. Let's have -5 plus -5. And then also down here, let's have -5. Oh, that's a terrible looking 5. Minus -5. Let's start with the top one. What did we say will happen? Well, whenever you have plus, you will go towards the direction of whatever the next number is showing you. So we have -5, and then from -5, which is somewhere, let's say somewhere here, -5, I want to move towards the direction of negative infinity another 5 units. So therefore, -5 will become, this will simplify basically, plus minus will hold, and then this will become -5 -5, and this will become -10. So we are -10 units, or 10 units towards the negative infinity. So somewhere here. On the other side, we have -5 minus -5. Now what happens here? We have minus operation, which reverses the direction we're going to move, indicated by the number. So -5 is on the negative infinity direction, so going from 0 to negative infinity, but we are going to reverse its direction, and we're going to move towards the opposite direction, which in this case is the positive direction. So it will simplify to -5 plus 5. And if we start from -5 and we move 5 units to the positive direction, so to the plus infinity direction, we will end up back at 0. And hopefully that makes sense. So when you have a negative number, that indicates that you should be moving towards the negative direction. And when you have a positive number, it should indicate that you're moving towards the positive direction. When you have addition, the direction is respected. And when you have subtraction, the direction is reversed. Multiplication is simply addition with extra steps. What does it mean to do 3 times 5, for example? It means add 3 copies of 5 to each other. So this is equivalent to 5 plus 5 plus 5. And at the same time, this is also equivalent to the other way. So you will have 5 times 3, which is 3 plus 3 plus 3 plus 3 plus 3. These are equivalent. Whenever you have multiplication, you are going to add as many copies of one number as the other number dictates. So either 3 copies of 5 or 5 copies of 3, which will give you the same result. And here we're going to follow the exact same rules as we followed earlier when we talked about directions. Let's say we have 2 times negative 3. When you have 2 times negative 3, this 2 is going to indicate that we're going to add together 2 copies of negative 3. So this is equivalent to negative 3 plus negative 3. So let's talk about what happens when we're talking about the other way. When we have 3 times 5, I said that it is the exact same way to do either 3 additions of 5 or 5 additions of 3. However, here, when I do negative 3 additions of 2, it doesn't quite make sense when you think about it. Because, well, how can I have negative 3 2's and add them together? Like, negative is, well, it means that they don't exist. They are, well, negative. It is a bit confusing, and at least in elementary school, a lot of kids get quite irritated, and they don't quite understand how it works. However, there is a rule of how to deal with this. When we had 3 times 5, there is another step that goes on. But once again, because we have simplified things, we have taken it out. Well, 3 is, like I said earlier, is nothing else but plus 3. And 5 is nothing else than. So the first thing that we actually do, which I guess nowadays we do in our heads because we don't have to think about it, is understand the sign or figure out the sign of the answer. So we know that 3 times 5 has an answer. What is going to be the sign? And here, because we have plus and plus, well, plus and plus, they don't cancel each other. They don't change each other. So what happens is that the answer, therefore, will become a positive answer. In this case, it would be 15. But in this case, what we really have is plus 2 times minus 3. So we have plus and minus. And like we said earlier, whenever you have plus and minus, minus and plus, whatever combination, minus will win. And what that means is that we're going to have the negative of whatever the answer of 2 times 3 is. And now we can apply the same logic that we applied to 3 and 5. It doesn't matter which number we get. We can either take 3 copies of 2 or 2 copies of 3. It doesn't matter because the answer will be 6. And I will put 6 now here in parentheses, but then eventually you will drop them. What you're going to be left with is negative 6, which is 6 units towards the negative direction when you multiply two negative numbers. So if you have negative 3 times negative 3, what happens? Well, we have negative and negative. And like we said earlier, when you have negative and negative, you get plus. So the signs then get dropped, and we're left with 3 times 3. And well, 3 times 3 is 3 copies of 3 or 3 copies of 3, which is plus 9. And then we drop the parentheses and we're left with plus 9. So that means we are 9 towards the positive direction. And because in mathematics we have oversimplified things, we don't even write this plus and we just say, well, the answer is 9. And I hope that makes sense, at least for now. So let's talk about division. Division is quite a complex operation because it's not as intuitive as the rest of the operations. So let's talk about division. What does division really mean? Let's say you have the number 15, and I tell you to divide it by 3. And like I said earlier, you can do division either this way or you can do it this way. Mind it that these both mean division. So what does 15 divided by 3 really mean? Well, division is actually not an operation. It is most like, or it is more like a question. How many times does 3 fit into 15? Unlike multiplication, it doesn't go both ways, actually. You cannot say how many times 15 adds or fits into 3. So it's in the sense like it's different than multiplication, that it can only be performed one way. So whatever you're dividing by is what dictates which way you're looking at it. 3 into 15. Now, when you're a kid, you start doing, well, if I have one copy, well, that would be 3. Still, I can fit more. So if I add another copy, that would be 6. Still, I can fit a little bit more. If I go 6, oh, that's 9. I can fit a little bit more. Plus 3, oh, that's 12. I'm almost there. Plus 3, well, that is actually 15. So how many copies did I have? I had 1, 2, 3, 4, 5. So the answer must be 5. And essentially, nothing changes except the types of algorithms that we use. As we become more experienced in mathematics, there's a lot of pattern recognition. Like immediately when you see 15 times 3 or 15 divided by 3, you know the answer, but it's not because you performed a complex algorithm in your brain to verify it. It's because you just simply memorized it. However, the concept is that we see how many times the number fits into 15. And there's just different types of algorithms to figure it out. When I had 15 divided by 3, don't forget that this is plus and plus. So this is equivalent to plus 15 divided by plus 3. And once again, because we had plus and plus, plus stayed. And that's why the answer is plus 5. Similarly speaking, when I have negative 15 divided by 3, which is plus 3, what happens is we're going to have plus and minus will win. And now you might be thinking, well, okay, now I have to add 3 into negative 15 and figure out how many times that fits there. Like, conceptually speaking, that does not really make sense. However, it does make sense when you realize that what is negative 15? Negative 15 is the distance from 0 towards negative infinity. So negative 15 sits somewhere here. Obviously not so close to negative infinity. However, I just made the scale a little bit small. So this distance is actually what we're looking out and we're looking to divide. So when we had plus 15 divided by plus 3, we were looking at the distance between 0 and plus 15, positive 15. And we had to divide that into 3 pieces. In the other direction, we did the exact same thing. So this size here is what we're trying to divide. So this negative here just indicates which direction the number is, but this is what we are dividing, the units from 0. So there's 15 units from 0 for on the positive direction for plus 15, and 15 units on the negative direction for negative 15. So in an essence, they are the same. It's just how many units and which direction we're going. So instead of going 3 times 5 units to the positive direction to reach 15 like we did in 15 divided by 3, we're going to go 3 times 5 to the negative direction. So we're going to move minus to the minus 5 first, minus 10, and then minus 15. And I hope that makes sense. So what it means is that numbers are nothing more than just their distance from 0 in this axiom. So when you have just normal numbers, and we will talk about different axioms later, but when you have just normal numbers, then you have just their difference from 0. So how far are they from 0? How many units are they from 0? In the next video, we will talk about another set of numbers called rational numbers, and we will also talk about their counterpart, irrational numbers, which will conclude the set of real numbers. I hope it wasn't too confusing. I know that talking about maths basics is something that you don't do very often because you have hard memorized how they work. However, I hope this shows you a little bit of the logic behind the things that we were taught to memorize and what they actually mean, because it is quite important. If you haven't grasped on a basic level how things work, it's very hard to build on that because of this concept of memorize everything and do everything like a parrot, where you just have memorized how to do things. Oh yeah, plus minus, like, oh yeah, you know how to do it, but it is very crucial to understand why you do it the way you do. Don't do it because you memorize it, do it because you understand how it works. And this is one of the reasons why I created these courses, is that I want you to understand how things work. Don't just memorize, understand. See you in the next one.